Uh, okay, Tala. So today we are going to discuss about the current and circuits, and we will be discussing the symbols of some components of the circuit. Before that, what we need to understand is basically current is a physical quantity, as we have other physical quantities such as you can say such as mass or time or displacement or speed, as these are some physical quantities. Current is also one of those physical quantities. So what does current mean? We start with the definition of current. Basically, the rate of flow of charges is called current. What does this mean? That we can say the number of charges passing through a certain area or a certain place in certain amount of time is called current. We represent it by a formula. Basically, in order to show current, we use the symbol I, and I is usually equal to Q by T. Then what is Q? Q is the number of charges passing through a certain area in time t is called current. So we can define that the current is the rate of flow of charges through a certain place is called current. So now what is charge? Basically, charge is an intrinsic property of matter. Every you can say every type of matter have a certain charge, and we represent the charge by q, and the unit we use for the charge is coulombs, and we represent the unit by c. So as we have units for every physical quantity, such as mass, for mass let us say we use kilograms, for distance we use meters, for time we use seconds. Similarly, for charge, we use the unit coulomb. Coulomb is basically the unit in which we measure charge. As we measure time in seconds or minutes or hours, similarly, we use coulombs to measure the charge. And for current, the unit we use is ampere, and we represent it by A. Okay, these are the necessary things which we need to understand in order to understand about the current. Basically, whenever we are talking about the current, we need to talk about the circuits in which the current is flowing, and those circuits consist of different components. Let us say in our circuits we can have resistors, we can have you can say capacitors, we can have inductors, and things like that. So as we go deep down this lecture, we will study some of those components that which things are included in the circuits and how current flows through them. So this was a basic introduction of the current. In your notes, it's written that electric current is a flow of electrical charge. Electrical charge will only flow around a complete closed circuit if there is a potential drop, potential difference. So a current can flow only flow if there is source of potential difference. The unit of current is ampere. Okay, so what is potential difference? Basically, you are familiar with the concept of battery, right? uh,
Yeah.
the battery is basically that source of potential difference, that source or that potential difference which forces the electron or the charges to move in the circuit. So this is the driving force. You can see that the battery or that potential difference is driving force, and that potential difference drives the electric charge to flow from a certain point, and this is how the current flows in the circuit. Now there is another important thing which you need to understand, that it's written that the current will flow only around a complete or closed circuit. Now what does this mean? It means that the current will only flow if it will have a complete path. Let us say if this wire is broken from here, let us say for example that the wire is broken from here. Now the current, if current is like flowing right like this, and it comes till this point, now what happens, it will not have a path, or you can say it will not have any connection to flow or to jump through this break and to complete the cycle. So the current will not flow in this circuit. So that's why we need to have a closed circuit in order to flow the current from that circuit. So are you okay with this till here?
Yeah.
So you are familiar with the potential, the concept of potential difference, that basically this battery is you can say is the source of the potential difference. Our potential difference is basically the driving force which moves the charge, due to which the charge will flow inside a circuit, right? So is it clear till here?
Yeah.
Okay. In a single closed loop, like one on the right, the current has the same value everywhere in the circuit. Okay. What does this mean? It means that you can see this figure over here. This is a single loop. Like it is a very simple circuit that it is you can say a battery is connected with a resistance, and there is a complete circuit. But practically we have very complicated circuits. So in practice or in our daily household, the circuits are not that much simple. So it is saying that if we have a single closed loop, then the current will be same everywhere. If you measure the current here, or if you measure the current here, or if you measure the current here, the current will be same. But if we have those complicated circuits, let us say, for example, a battery is connected and there is a resistor over here, and it is also connected with another resistor, let us say this, and it is further connected with the battery. Now the current might be different from this point to this point. So in a single loop circuit, which is a simple one like this one, the current will be same everywhere. But in those complicated circuits, the current will not be same anymore, right? Potential difference. We commonly use the name, we commonly call potential difference as voltage. And basically, as I have told you earlier, that voltage is that driving force which pushes the charge around, that due to which the charges flow. Now, this potential difference is also a physical quantity. So we also need a unit for this particular physical quantity as well. And the unit we use for potential difference is volt. You are familiar with the units, right? If you don't know about the units, we can discuss the concept of units a bit.
Isn't potential difference V?
Yes, potential difference is measured in volts. Basically, units are you can say in order to completely describe any type of physical quantity, we need at least two things. The first one is the magnitude of that quantity. Let us say let us consider the force, example of force. When we want to tell you that how much force someone is applying on something, we need two things. First, the magnitude. Let us say the 5 Newton. So let us say I say that Tala is pushing the wall with a force of 5 Newton. So in order to explain the force completely, we needed two things. One, the magnitude, which is 5, and the other thing is unit. So whenever you are talking about any physical quantity, you need at least two things to describe that. First, the magnitude, and the second one is unit. So the unit we use for the potential difference is volt, and the symbol of the volt is V, right?
Yeah.
Okay, if you have any confusion till now, you may ask.
Wait, I don't really get the last part when you're talking about potential difference.
Okay, Talha, basically, potential difference is that driving force. You can say potential difference is basically this battery, right? This battery is the source, or this battery is something due to which the charges will flow in this circuit. You can say that the cause of electric current, yeah, or electric, the flow of electric charges is, you can say, is potential difference. Basically, potential difference is something which pushes the charges to move, and this push by this potential difference will cause that current, right?
Yeah.
Now, are you comfortable with this concept, or I can elaborate it more?
I know it's fine now.
Okay, so now moving towards another important concept. Whenever we are talking about the circuits or electric current, as I have told you earlier, that we have different components in the circuit, like we have potential difference or battery, we have the current, we have charges, and now we are moving toward another important concept, and this is resistance. Resistance, what comes in your mind if I talk about the resistance in general?
Something that's like in the way of you.
Yes, something something which opposes you, right? Which
Yeah,
which don't let you flow, and or which pushes you backward, right? In general, we
yeah,
talk about now in electric circuits or in physics, when we talk about resistance, basically resistance is something which opposes the flow of charge, or you can say which slows the flow of electric charge, right? Or you can say which opposes the electric current. Are you getting my point? So resistance
yeah,
is something which stops the electric current in a circuit. Let us say, for example, I'm giving you a very general example in this circuit. Let us say I have this circuit, and now let us say I have current of, let us say, 7 ampere till this point. Now when this current passes through this resistance will oppose this current, right? So when it comes out from this resistance, some of this electric current is consumed by this resistance, and it might be like 3 ampere after this resistor, or it might be 2 ampere after this resistor, or you can say that resistor opposes the flow of current or flow of charges, right?
yeah,
So resistance is that something or that property of matter which opposes the flow of charge. And there is an important thing, resistance is also a physical quantity. So the unit of resistance is ohm, and we represent it this by this symbol of sigma, right? So this is resistance. Whenever we call resistance, it means the opposition of flow of charge or a position of flow of electric current, right? So the current flowing through a component depends on the potential difference across it and the resistance of the component. Now whenever we are talking about the current that is flowing through this circuit, it will be depending upon two things. First, the potential difference, and the second, the resistor. Now how this current depends on these two things? Basically the current have a direct relation with, you can say, battery or potential difference. If you have larger potential difference or larger battery, more current will flow through the circuit, and if you have smaller potential difference or smaller battery, the less amount of current flow through the circuit. But as far as the resistors are concerned, it will have a opposite relation with, you can say, electric current. If you have a large resistance in the circuit, the current flowing through the circuit will be small, and if you have a small resistor, the current flowing through that circuit will be large. Are you getting my point?
yeah,
We will discuss this in detail with an equation, but it will be after some time. So right now, total charge through a circuit depends on a current and time. Now on which thing the total current passing through a circuit depends, or total charges passing through a circuit depends. When while defining current, I have shown an equation to you that the current is equal to I is equal to Q by T, that we define current as the amount of charges flowing in a unit time is called current. Now if we want to know that how many charges are flowing through a particular point in a unit time or in a certain time, then we will find this by rearranging this equation, and we will get Q is equal to I into T, the product of current and the time for which the current is flowing through the circuit will give us the total charge that will be flowing through that circuit, right? So we can say that the total charge that is flowing through a circuit depends on two things, and these two things are current and time. Or alternatively, if we talk about the current, that how much current is passing through a circuit, then that current will depend upon the number of charges that are flowing through that circuit in particular amount of time. So are you following me till here?
What does Q mean? Like charge flow, what does that mean?
Q is basically the charge we were talking about, that the amount of charge that is flowing through that circuit, right?
Okay.
If you have any confusion, you may ask Tala. Feel free to ask.
So the charge that's flowing through the circuit.
Yes, that is Q.
Okay.
You see, we have defined the current like this, that the current, what is current? Current is basically the amount of charge Q that is flowing through a circuit in a time T will be called current, right? Now, when we rearrange this equation, Q, the charge flowing through, if we want to know that how much charge is flowing through this circuit, then how we will find it? If we know that, let us say 5 ampere of current is passing through this circuit for, let us say, 30 seconds. So we will just multiply that 30 seconds with 5 ampere and we will get the amount of charge that will be flowing through that circuit, right?
Okay.
Are you clear with this concept, or I can further elaborate it?
No, it's fine. I get it now.
Okay, here is an example. Let us solve this example. It will further clear your concept. A battery charger passes a current of 2 ampere through a cell over a period of 2.5 hours. How much charge is transferred to the cell? That there is let us say you have a laptop and you have connected the charger with that laptop, and you are charging it, charging the battery. Now 2 ampere of current was passing through that battery for 2.5 hours. Now you need to know that how much charge was passed or how much charge was stored in that battery. So how will you solve this? You will solve this by using that same equation. Q is equal to IT. We are given with the current that is passing through and the time that is for which the charger was connected with that laptop. Now it is given that 2.5 hours, but we need to have the time in the units of seconds. So we will convert this into seconds. How? We have, in 1 hour we have 60 minutes, and in 60 minutes we have 60 seconds. So in 2.5 hours we multiply it by 60 minutes, and then we will further multiply it 60 with 60 seconds, because 1 minute will have 60 seconds. So that's why we multiplied it with 60 again, and we multiplied it by 2, which is the current given. So we will get 18,000, and then we, at the end, we have a C written over here. And what does this C means? Basically C is coulomb, the unit of a charge, right? The unit of the charge
Okay.
is called coulombs, right?
Okay.
Tara, if you have any confusion in this problem, you can ask.
No, it's fine. I get it.
Okay, the size of the current is the rate of flow of charge. Basically, this is the definition of current. When current flows past a point in a circuit for length of time t, then the charge that has passed is given by this formula. We have discussed this formula in a bit detail. More charge passed around the circuit when a larger current flows. Definitely, if you have large current flowing through a circuit, you will have large number of charges that will be passing through that particular circuit, right?
Yeah.
Okay, so learn these diagram samples. As I have told you that there are many components which are used in the circuits, in the practical circuits. So you need to remember the symbols of these circuits. So first of all, the symbol given is the cell. Basically, a battery usually have two terminals, right? We have two terminals of a battery. Have you seen any battery?
What do you mean? Like a
Like
cell?
a cell, yes.
Oh yeah, I have the
Uh,
small one, the like
yes.
really small cylinder.
That cylinder, if you see that cylinder, at both the ends of that cylinder, you will have a positive symbol on the one side and a negative symbol on the other side of that cell. Basically, these are the terminals of that battery, or that you can say cell, right? So basically, in this symbol again, you can see that we have a positive plate and a negative plate, right? What does this battery do? It sends the positive charges from this end to this end, and similarly the negative charges from the other end to the component, right?
Okay.
So moving forward, a battery usually have multiple cells, so that's why it have this symbol. These are just symbols. You need to remember that whenever there is a circuit drawn, if the symbols are given, you need to know that what does this symbol represent. Similarly, this symbol, you see that it is not connected on both sides. So this is an open switch. When we like, for example, when we turn off the electric bulb, it in that condition the switch is open, the current will not have a connected path to flow. So that's why the bulb gets off, turned off, right?
Okay.
And when the switch is closed like this, the current will have a complete path, and it will flow through the circuit, and the lamp or the electric bulb or electric light will be turned on, right?
Okay.
So a filament lamp or a bulb, we represent this by this symbol. Similarly, a fuse is represented by this symbol. LED is basically a light emitting diode. You need not to know about the details of LED, but it is just represented by this symbol. Similarly, a resistor. Now you need to understand the difference between resistance and resistor. Basically, resistor is a physical component which we use in the circuit. We connect resistors in order to, you can say, decrease the current flowing through that circuit, right? So resistor is the
Yeah.
physical component which we physically attach in that circuit, but resistance is that property which is offered by this resistor to the electric circuit, right? So I hope you got the point that what is the difference between resistor and resistance.
Wait, what's so can you repeat what resistance is?
Basically, let us say physically we have a circuit in your lab, let us say, right? You are
Yeah.
doing an experiment in the lab. Now resistor is something which you can touch, you can feel, you can connect it in the circuit. Resistor is something physical which you can connect in that particular circuit in order to decrease the current, right? So resistor is physically something which you can touch, or let me show you an example right here.
Okay.
So you can see there are many images over here. All these things, all these components are resistors. We connect them in circuits, right? Resistor is something
Yeah.
which we can touch, we can see, and we can connect it in a circuit. Now, why we use this? In order to decrease the amount of current that is flowing through that circuit, right? Now, what is resistance? Resistance is that property or that thing which we cannot see, we cannot touch it, or we cannot see, but it is the property which is offered by the resistor to the circuit, and due to this property the current that is flowing through that circuit is basically decreased. Now you got my point that what is difference between resistor and resistance.
Yeah.
If you are not still clear, I can give you further an example.
No, it's fine now.
Okay,
Because I didn't like see how it actually looks like. That's why.
so now is it fine, the
Yeah.
how it looks like the resistor?
Yeah.
Okay, so this is the symbol of resistor. Whenever we connect that resistor in a circuit, we represent it by this symbol, right?
Okay.
Oh, okay. Now we have certain types of resistor which have variable values. Like sometime it is flowing, let us say, I'm giving you just an example. Let us say the current flowing through a circuit was 10 ampere. Now we connected this variable resistor in the circuit. Now at a moment it will decrease the current to 9 ampere. It might decrease the current to 7 ampere. It is, its values are changing regularly, right? So as we have seen earlier, that when resistance is small, more current will flow, and when resistance is large, small current will flow. So when we have a variable resistor, its resistance changes. So when its resistance changes, the current flowing through the circuit changes accordingly, right?
Okay.
So similarly, we have ammeter, and an ammeter in electric circuits is a device which is used to measure the current, that how much current is passing through that circuit, right? And similarly, we have voltmeter. Voltmeter is again of an electric device which is used to, you can say which is used to measure the potential difference across any component of a circuit, right? We can see it also, that I would like to show the picture of voltmeter and ammeter so that you can better imagine that. So voltmeters and ammeters look like this. Now we have some digital voltmeters and ammeters as well. Previously, we had voltmeters and ammeters like that. They showed whenever these are connected in a circuit, they show the value of current passing through that circuit and the potential difference across that circuit. And now we have
Yeah, we used this in school, I think. We used this in school before.
so I hope you are familiar with these things. Now
Yeah.
we have such digital multimeters or digital ammeter and voltmeters. It gives us the values in decimals, and previously we had such such, you can say, uh, analog type of voltmeters and ammeters. But now we have advanced these voltmeters and ammeters, and we have these digital voltmeters and ammeters, right? So are you now have you got the concept of this voltmeter and ammeter?
Yeah.
So these are certain things which you need to know about the electric circuit. Similarly, we have diodes, we have LDRs, we have thermistors. I just give you a little intro to these components. Basically, a thermistor is a resistor which depends upon the temperature, like it changes with temperature, and LDR is light depending resistors. That its resistor is depends upon, you can say, the light, that the resistance of LDR depends on light. If we have more intense light, like in the day, if we have more light, so resistance will be small, and if we have less light, the resistance, like in the evening, the resistance will be large. Similarly, thermistor, if we have more temperature, the resistance will be small, and if we have less temperature, the resistor will be large. So this is LDR and thermistor. Now we don't need to go in the depth of this LDR and thermistor at this stage. Now moving forward to a question. Can you solve this question? This is very easy. Numerical question number 1. Can you read it?
A laptop charger passes a current of 8 is it ammeter
8
amps or
8
8
amperes.
amps?
Basically, ampere is the unit of current. We measure current in amperes, right?
Okay,
Like we
ampere.
measure mass in kilograms. Similarly, we measure current in amperes. Like we measure the time in seconds or minutes, right?
Through a laptop battery, calculate how long the charger needs to connect to the battery with 2020. Wait, yeah, 28,800. Is that current?
Coulomb. Coulomb is the
Oh
unit
yeah,
of charge.
coulomb of charge to be transferred to a laptop.
Now, can you solve this question?
So, yeah,
Okay, you can solve it on the page if you have.
yeah, okay. I got the answer.
Yes.
So was it um was it six that yeah 3,600 seconds.
How you solved that?
So the formula
Mm-hmm.
is Q equals I times T,
Right.
and Q is the charge flow charge, that's coulombs,
Yes.
and it tells us that it's 28,800,
Right.
and I is the current, so I did 28,800 divided by 8, that gives me 3,600.
Okay. Then what will be the unit that you will be using for time in this case? You need to mention some units with time as well, right?
Seconds.
Yes. For this, you need to write seconds with the value of time. Why? Basically, you can say the unit of charge, the SI unit or System International Unit of Charge is coulomb, and the System International Unit of current is ampere. So we will again use the System International Units for the time as well, and the International Units for the time are seconds. So that's why we need to write seconds with time, right?
Okay.
If you have any confusion with this, you may ask.
No, it's fine. I got it.
Okay. So now moving forward, a student creates a simple circuit containing a battery, a switch, and a bulb. He connects them all in a single closed loop. Draw a circuit diagram for this. It's very simple. Let us say we have a switch over here and it's a closed loop. So, and we have a battery, and how we represent a battery? We represent a battery like this, and then we positive terminal and negative terminal, and then a bulb is connected, and for bulb we use this symbol. So this is how we will represent it by a circuit diagram, right? A switch which is closed over here, and a battery and a bulb, right? So
Okay.
this is how you will represent it. It was simple. Okay.
Yes.
Okay. Now moving forward to resistance. We have discussed resistance a little bit, and now we have a formula over here. V is equal to IR. What does this mean? Basically, this formula is called Ohm's law. Have you heard about it before?
Out of what?
Ohm's law.
Um, wasn't it? I know it's got to do with resistance, but I forgot what it is.
Have you heard about it before?
Yeah, we did it in school before.
Okay. Basically, uh, we have discussed three important things in an electric circuit. The one is current, the other thing is resistance, and the third one is voltage or potential difference, right? Voltage and potential difference are same things, right? So
Yeah.
we have three things. Now, what have Ohm done? that he related all these three things. He gave us a relation which is this V is equal to IR, and from this relation you can see that voltage and current have direct relation. Initially we have this V is directly proportional to I. What does this mean? If we connect a larger battery in a circuit, more amount of current will flow. And if we connect a smaller battery in a circuit, small amount of current will flow, right?
Yeah.
For example, let me give you an example. For example, if you have a toy car, right? So if you have small cells for that, it will small amount of current will flow through that car. And if you have a larger battery, a larger amount of current will flow through it, right? So a potential difference and current have a direct relation. Now, in order to remove this proportionality constant, we know that whenever we replace this proportionality constant with equality, we need a constant. Do you know about it? In mathematics we do this.
A constant.
Whenever we replace this equality with this proportionality, now what does this proportionality means? It means that if voltage is large, the current will be large, and if voltage is small, the current will be small, right?
Okay.
Now, if we want to remove this potential, this proportional sign, and we want to replace it with an equal sign, we need to use a constant. Do you know about it?
No, I don't know.
Okay, just leave it. Don't make the things complicated. Basically, what does this Ohm's law mean? It is equal to V is equal to I R. This Ohm's law basically relates potential difference, current, and resistance in a circuit, right? So what does this Ohm's law means? That if you have a large potential difference, the more current will flow through the circuit. And if you have small value of battery or potential difference, you have connected a small battery in that circuit, small amount of current will flow through this circuit. Is it right till here?
Yeah.
Similarly,
So the higher the potential difference, the
yes,
higher the current,
yes, right,
and the lower it is, the lower the current.
exactly. Now, it is if it is clear till here. Now, the next thing is relation between the current and the resistance. Now, the current and resistance will have and you can say opposite relation with each other. If resistance in a circuit is high, we know resistance is opposition to the flow of current. If resistance is high, if in a circuit you have a larger opposing force, so you will have smaller amount of current flowing through that circuit, right? And if you have smaller resistance, larger current will flow through that circuit. So are you getting my point till here?
So it's like the opposite with
Yes.
current and okay.
Potential difference and current are same, have the same relation, direct relation. If one is increasing, the other will be increased, and if one is decreasing, the other will also decrease. But in case of current and resistance, we have opposite relation. If if resistance is large, small current will flow, and if resistance is small, large current will flow. So is it okay till here?
Yeah.
So this is Ohm's law, which relates potential difference, current, and resistance in a circuit. So I hope you are clear with it.
Yeah.
Okay.
Yeah.
Now here is simple experiment for the investigation of resistance. There is a formula linking potential difference and current. We have seen that that formula V is equal to IR links the potential difference and current. The formula linking potential difference and current is very useful, and we call it Ohm's law. And potential difference is equal to current into resistance. Same thing which I have told you, that V is equal to IR. This is the same formula. You need to remember this formula, because in many numericals this formula will be used. There is an example given, a simple example, that a 4 ohm resistor is connected in a circuit. It has a potential difference of 6 volt across it. What is current flowing through the circuit? Now simply we had V is equal to IR. Now the values of potential difference is given, the value of resistor is given. We need to find the value of current. We will just rearrange this formula. I is equal to V by R. We will put the value of potential difference, which is equal to 6, and we will put the value of 6 volt, and we will put the values of resistance, which is 4 ohm, and we will get about 1.5 amperes, right? So this amount of current will flow through this circuit. So I hope you are clear with this.
Yeah.
Okay. If you are clear till this point, now we are moving forward. Okay. We have seen these resistors, right? Now these resistors, in these resistors, the resistors depend on different things. Like these are the components of, these are the separate components which we are connecting in a circuit in order to provide resistance, or in order to decrease the amount of current. But the wire from which the current is flowing, it will have its own certain amount of resistance, right? That you can say that it will, the wire in through which the current is flowing, it will also opposes the current. Are you getting my point?
Yeah.
So the resistance of that wire depends on different things. We have a formula, you need not to remember it, it's just for your knowledge. R is equal to rho L by A. This is resistance, this is resistivity, this is the length of the wire, and this is the area of the wire. So the resistance of that wire depends on the resistivity. Basically, resistivity is the property of material from which the wire is made up of. Like for example, we have copper wire, we have brass wire, and we have different type of materials from which the wires are made up of. And these different materials have different resistivities. So the resistance of the wire depends on the resistivity, that is from which material it is made up of. Similarly, the length of the wire through which the current is passing through, and the area of the wire through which the current is passing through. So these are the factors on which the resistance of the wire depend. Are you getting my point?
Okay. Yeah.
If you have any confusion, you can ask.
Um. Wait. So we're not expected to know this in school, right? Or
Yes,
do we
it
need?
was just for your knowledge that
Oh,
how
okay.
things are depending upon how resistance of a wire is changing.
Okay.
Okay. Now in a circuit, we will discuss it later, but in a circuit, we can connect more than one resistor, right? For example, let us say we have this battery, okay? We will discuss it in detail, but I just want to give you a little taste of this concept. We represent resistors like this. Let us say we have connected one resistor, let us say one resistor over here, and we again connected another resistor over here, right? So this is how we have connected R1 and R2, two resistors in a circuit, right? Similarly, we can also connect the resistor in this way. We have resistor R1 over here and R2 over here. Or just a second. And R2 over here. We have connected this R1 and R2 in the circuit, right? Are you following me till
Yeah.
here? Now, you can see
Yeah.
that in this case, one end of these resistors are connected with each other at this point, and the other end is connected to the batteries, right? But in this case, both ends of the resistors are connected with each other. You can see at this point and at this point, both ends of these resistors are connected with each other through a wire, right?
Yeah.
So whenever in a circuit you have two resistors which are connected like this, that their both ends are connected with each other, and then these are further connected with the battery, then this will be called parallel combination of the resistors. This will be called parallel combination. And whenever the resistors are connected in this way, that one end is connected, one end of both these resistors are connected with each other and the other ends are connected with the battery, then this is called the series combination of the resistors. Similarly, we can have more than two resistors connected in a series circuit. We can have 3, 4, 5, or even more than that, more than 5 resistors which are connected in the circuit. And in a particular circuit, we can have resistors which are in series and which are also in parallel. But you need to understand that what it means there by parallel resistance and by series resistance. Now, are you familiar with this concept? What does it mean by parallel combination and series combination?
So parallel is like when there's an extra like set of wires, like it splits in half, and
No.
series is one whole.
Basically, the right concept of the parallel resistor is that both of their ends, you can see one end of this R2 is this. Let me use another color. One end of this R2 is this, and other end is this. Similarly, one end of R1 is this and the other end is this. Now both of these ends, you can see these both of these ends are connected with each other through wire, right? But in this
Yeah.
case, only one end of R2 and R1 are connected with each other, while the other end is connected directly to the battery. So this is the difference between series combination and parallel combination.
Okay.
So now I guess you observed this concept.
Yeah.
If you have any confusion still, you can ask. Tala?
No, mine now.
Okay. Okay. So when we have more than one resistor in a circuit, we need to have an equivalent resistance, which is equal to that how much resistor in total, how much resistance is provided to the circuit, right? And that total resistance is called the equivalent resistance of the circuit. That how much total resistance is provided to the current in that circuit, right? So that total resistance is different for the parallel combination and for the series combination. These have different formulas, but we will study it later. You can see uh, here. This is given in detail, the series circuits and the parallel circuits. We will discuss these formulas over here. But till now, you need to understand what you need to understand is that what it means by the series combination and what does it means by parallel
Hello.
combination. Hello, Talha, are you there?
Hello. Oh, yeah, I can hear you now.
Do you hear me?
I can hear you now. Before I couldn't, now I can.
Okay, I was saying that till here you need to understand that what it you only need to understand what it means by parallel combination and by series combination. We will study it in detail when we move till this page over here. You can see that the series circuit and the parallel circuit is given in detail over here. So we will discuss it later, right?
Okay.
So there is another thing I want to tell you. Okay, whenever we have series combination, okay, let us leave it for the next topic. We will discuss it there. Okay, whenever we have a parallel combination, keep this thing in mind. Whenever we have a parallel combination, as I have drawn here, that let us say we have this combination, we have resistance
Yeah.
R1 over here and we have resistance R2 over here, and then these both resistors are connected with a battery with a battery, and this circuit is complete. Now we have two components in parallel, right? One is this one and the other one is this one. You need to remember that whenever we have two components in parallel, the voltage across both these components, that if we measure voltage at these two ends, or if we measure at these two ends, the voltage will be same in parallel circuits, right? That in parallel combination, the voltage across both the components, if we measure voltage V is equal to, let us say 5 volt here, the voltage will be, again it is understood that the voltage will be 5 volt parallel to it. Again, the component which is in parallel combination will have the same voltage. Okay, you got my point?
Yeah.
And in case of series circuit, let us say we had this series circuit R1 and R2, and it is connected to a potential difference V. Now in this case, the current that is flowing through this circuit will be same, but potential difference across these 2 points will be different. In this case, the potential difference was same. In case of parallel combination, the potential difference was same, but in case of series circuit, the current is same. So you got my point, that the current flowing through the series circuit is same, but the potential difference is different. Are you getting my point?
So is this for series?
Sorry?
Are you talking about series circuit?
Yes, in series, we have the same current flowing through that. Let us say if 5 ampere of current is passing through R1, then it is understood that from R2, we must have 5 ampere of current passing through. That means that if two components are in series, the same amount of current will pass through them. But if two components are in parallel, the potential difference across these two components will be same, but the current flowing through this through R1 and R2 is different. So you got my point now?
Yeah.
If you have any query, you can discuss, Tala. I'm feeling like you might not absorb this concept. It's a little difficult or tricky, you can say. So that's why I'm a bit concerned that if you are understanding this, then we should move forward. If you are not clear with anything, we can discuss it in detail.
Can you please like repeat it so I can note it down so that I can like remember it?
Oh, okay, no issues. Okay, write down. Whenever we have two components, or whenever we after components, you can write in bracket that we have two resistors in parallel. Whenever we have two components in parallel, the potential difference across both the components will be same. You can draw this figure to remember it as well. This
Yeah.
parallel, you can draw it on your paper as well in order to understand it. We will discuss it in detail when we move forward to that topic now. The topic which is of series and parallel combinations, we will discuss it in detail, but now I'm just giving you a taste of this a bit earlier.
Wait, so potential difference is the same?
It will be same across both the components. But in case of series combination, or you can say, you can write, but in case if two components are connected in series, if two components are
Yeah.
connected in series, then the current flowing through both the components will be same. Then the current flowing through both the components will be same.
Are the same.
Have you noted it down?
Yeah.
Now give it a read. Now give that statement a read and see if you understood it or not.
Whenever we have two components that are parallel, the potential difference is the same on both sides.
Across the
But
both
when
across
they,
both the components. What does it mean? That if we measure the potential difference of R1, it will be the same as we will have the potential difference of R2. The potential difference of R1 and R2, both the components will be same. So you got it?
Yeah.
Okay. So moving forward, you can write the next, read the next statement.
From where?
You can,
Okay. But in a series component,
in a series
uh,
circuit.
in a series circuit, I've got
Mhm.
some. Yeah. In a series circuit, the current flowing through both components are the same.
Yes, and you can draw this diagram with that in order to remember it. That if the
Okay.
5 ampere of current is passing through R1, then from R2 again the same current will be flowing.
Okay.
So you got it now?
Yes.
Have you read these topics in your school or not?
I have done it a bit in school, but I think I wasn't in for one of the lessons. That's
Now,
why.
now you understood it properly.
Yeah.
So that's great. That's what I wanted. That I wanted you to overcome those deficiencies which are left in the school. Okay. So now we have discussed that we have ammeter and voltmeter, and I have also told you that what does ammeter means and what does voltmeter mean. Basically, I have told you that ammeter is an electric device which is used to measure the current flowing through any circuit, right? And
Yeah.
we have also discussed that voltmeter is something, an electrical device which is used to measure the potential difference across any component in a circuit. So these are things. Give it a read. It says that what does ammeter do? It measures the current in amperes. Amps means amperes. You can write it on your notes as well. Amps mean amperes. Ampere is the unit of current, right? So ammeter is used to measure the current in amperes flowing through the test wire, which we are testing, or through which we need to measure the current. So this ammeter is used. Now, whenever we connect this ammeter in the circuit, we use it in series because we know that in series, that's why I have told you that concept earlier, because uh, why we connect this ammeter in series, because we know, let me represent it with a figure. Okay, whenever we connect a an ammeter, we connect it in series. Like you can see that
Okay.
there is a resistor R1 and there is an ammeter connected over here. Now, if we want to measure the current that is flowing through this resistor, we connected an ammeter in series. Why we did so? Because we know that in series the current will be same. So that's why we just connected an ammeter in series with that resistor, or through with that wire through which we want to measure the current, right?
Yes.
So the second point says the same, that the ammeter must always be placed in series with whatever you are investigating. That through any component through which you are measuring the current, you need to connect it in series, right? You got my point?
Yeah.
So that's why we have discussed that point earlier, that it's just written over here, but you need not to remember it. Rather, you have a concept that why we keep this in series. Similarly, if you want to measure the potential difference across this component, we will use this voltmeter in parallel to this circuit, in parallel to that resistor. Why so? Because we know that the potential difference is same across the parallel components. The potential difference at these two ends will be the same, which is the potential difference at these two ends. So that's why we connect voltmeter in parallel to the circuit and the ammeter in the series to the circuit. So now you got my points.
Yeah.
If you have any confusion, Tala, please do ask. Don't hesitate to ask.
Right. So voltmeter is in series.
No,
You're
voltmeter is
saying.
in parallel, because voltmeter is used to measure the voltage, and we know that voltage is same in parallel circuits.
Oh yeah. Okay.
So voltmeter is in parallel, and current ammeter is in series, because we
Series.
know that in
Yeah.
series the current is same. So whatever current is passing through this resistor will be passing through this ammeter, and we will measure that current which will be passing through ammeter, through this ammeter, right? So we whatever the readings this ammeter will be giving, the same current will be flowing through R1. So this is how we can find the current that is passing through R1, right?
Okay.
And similarly, in case of potential difference, we know that potential difference is same in parallel. So that's why we connect it in parallel. So whatever the potential difference across these 2 points will be, it will be the same what is across this resistor. So do you get my point now?
Yeah.
If you have any confusion, I'm saying over and over it again, that please do ask, so that if the things are clear, then we should move forward. And if you have any confusion, that then we should clear that confusion first and then move forward.
So just to justify,
Yes.
voltmeter is in a parallel circuit
Yes.
because the potential difference is same on both sides.
Yes.
And then ammeter is in series
Right.
because it's measuring the current
Exactly.
that is flowing through both sides that are the same as well.
Yes, it will be same through the resistor, and it will be same through the ammeter. So this is why we connected it in series. So I guess you got my points now.
Yeah.
So moving forward, we can see that what is written over here in your notes, that voltmeter, it what does it do? A voltmeter measures the potential difference across the test wire, and the unit of potential difference is volts, of course, I have told you. And the voltmeter must always be placed in parallel around whatever you are investigating, right? That anytime you are measuring the potential difference across any 2 points or across any component, you need to connect the voltmeter in parallel. So not around any other bit of the circuit, example, the battery. It means that you need not to connect it in series, rather than you have to connect it in parallel. So I guess you are clear with these concepts.
Yeah.
So should we move forward, or do you want to take a break of 5 or 10 minutes?
Um,
It's
what's
up.
the time?
It's up to you. It's
I
8:10.
I can continue because I don't have any like fatigue or
Oh, okay.
rest.
That's great. That's great. Okay. So I was just asking that if you get bored, so you can just refresh yourself, and then we can continue again. So if you are fine, you are enjoying the lecture, then that's fine. That's great. No issue. So there is a practical which is given over here, that you can find the current and the voltage in the lab. So I guess we need not to read it, or if you want to me to read it, we can do that as well. This is just a practical, a lab practical.
Yeah, let's go for it together then.
Should we do it together?
We can just like go through the points really quickly.
Okay, so it is saying that attach a crocodile clip. Are you familiar with this crocodile clip?
Yeah, it's used to connect with the wires.
Yes, exactly. Now it is saying that attach a crocodile. Let us say we have this wire, we have this long wire. It is saying that attach the crocodile clip at this point at 0 centimeter. Let us say at 0 centimeter, and the second crocodile clip at this point, and the difference between them is 10 centimeter. Now the length is 10 centimeter. Now when both of these clips are connected, now you can close the switch and let the current pass through this wire, and then measure the potential difference and current flowing through this wire by using voltmeter and ammeter. What it says that now you note down the potential difference, the current, and the length. Now you remove this, turn off the switch, it means open the circuit, and remove this clip and move it further 10 meter away, so that now total length will be 20 centimeter. Now again measure the current and the potential difference, and you can say, and the length, and now you can find the, you can say, the impact of the length on the resistance, the current, and you can say the potential difference. As I have given you a formula that R is equal to rho L over A. Now you can say that resistance, you can see that the resistance have a direct relation with the length. So when you are increasing the length, it means the resistance is increasing. And if the resistance is increasing, it means the thing, the current which you are measuring will be smaller in the in the case of longer wire. So are you getting my point? So this is how you can see that how resistance will be varied, or how current and voltage will be varied when we changes the length, right?
Yeah.
So have you got that point or not?
So we're measuring the resistance of
Basically,
that
we cannot
electrode
measure the resistance directly. Rather, what we do, we measure the potential difference and we measure the
using the
current.
formula.
Yes, we measure the
Yeah.
voltage and the current through voltmeter and ammeter, and then we use those two things in order to measure the resistance, right?
Okay.
So you can see this graph. Can you see this?
Yeah. Resistance and
Uh,
y of length.
yes, and
Yeah.
resistance versus length. Now you can see that when the length is increasing, the value of resistance is also increasing in this graph, right? If we take this
Yeah.
point, let us suppose, let us say, now at this point, the value of length will be this and the value of resistance will be this. But when the length is increased, let us say this point, the resistance will be increased to this point, right? So when the length is increasing, the resistance is also increasing, and it justifies that formula R is equal to rho L over A, right? That if the length is increased, the resistance will be increased, and if the resistance is increased, it means we have smaller values of current. And in case of potential difference, R is equal to, we generally, when we had V is equal to IR, and from this R is equal to V by I, it means that although we have seen that resistance and current have opposite relation, but resistance and potential difference have direct relation. So the longer the wire will be, we will have smaller values of current and larger value of potential difference, and it means we will have larger values of resistance as well. So I guess you got my points now.
Yeah.
If you have any issues, you can ask.
No, it's fine. I get it.
Okay, so should we move forward to the next concepts?
Yeah. Okay then.
Okay, so there is another example. Can you solve this example?
Which doesn't. An appliance is connected to a 230 volt source. Calculate the resistance of appliance with a current of 5. Um, what does the A stand for?
Uh,
Um,
this A means ampere. Ampere is
Ampere.
basically the unit of current, right? Ampere, right? And it is represented by this A.
5 ampere following through it. So
So Talab, please give me a second. That I want to know that are you now familiar with this ampere and coulomb and volt or not? We can discuss it again. There, what it means by ampere and volt and coulomb. I guess you are facing a bit of, you can say, difficulty
Yeah,
in
no,
understanding
it's
this.
a bit because of there are a lot of symbols to memorize.
So there is a solution for this. You can write. Okay. Uh, on your notes, please write down.
Okay.
I will be writing over here. Mm, okay. So we have basically, let us say, three things: quantities. We have different quantities. We have their units. Do you know what units are, right? Or not?
Yeah. Like what we use to show to like, for example,
Hmm.
for centimeters it would be cm. I mean
No, symbol
centimeter.
for centimeter, cm is the symbol. Units are different things. For example, I consider mass, or I consider time. Let us say that an athlete, let us say Usain Bolt, has covered a distance of 100 meters in 11 seconds, right? Now, in order to describe that time, we needed a unit, that is second. Now let us give another example. Whenever you want to buy some grocery, you went to grocery store, you need to buy some vegetables. Now whenever you are buying something, let us say you are buying potatoes, now you will ask the shopkeeper to give you 5 kg of potatoes, right? So it means that you need to describe the quantity by its units. Now, when you say that 5 kg, that gives me 5 kg of potatoes, it will be completely understood. Similarly, when you say that the distance from my school to my home is 12 kilometers, now that kilometer is the unit, and that unit is necessary in order to determine a physical quantity. Let us say you simply say that the distance from my home to my school is 12. No one will understand that what does 12 centimeter, 12 meter, 12 kilometer, what does it mean? So in order to explain a physical quantity completely, you need a unit as well, right? Now you are, I guess you got the concept of units. What does units mean?
Yeah,
If you are still confused, I can give you more examples.
like it's the measurement of what it's what we use to measure something.
Yes, exactly. I was discussing it with you earlier that basically the units are basically the measure of something. Like if we want to measure the mass, we measure it in kilograms. If we want to measure time, we measure it in seconds or minutes or hours. If we want to measure the distance, we measure it in meters or kilometers or centimeters. Right? So these are what units are. Right?
Okay.
So now, Talha, we have three different quantities. First of all, we have current, right? Three important quantities. We have current, we have potential difference. I'm writing it PD, potential difference, or you can say voltage, and we have resistance, right? We have these three important things in a circuit. We have resistance, we have voltage, and we have current, right?
Yeah.
Now, when we measure current, we measure it in amperes. Ampere is the unit of current. Like we had, I'm giving you an example of time. As we had the unit of time as second, similarly, seconds, similarly, the unit of current was ampere. Current is ampere. Similarly, the unit of potential difference is volts, right? And the unit of resistance is ohm. Are you getting my point?
Yes.
So when we want to give them a symbol, we write A for ampere, we write V for volt, and we use a Latin sigma symbol, which is like this, for ohms, and we use S for seconds. So you got it now?
Yes.
You can write it on your page so that you can memorize it.
Okay, I'm writing it down now.
Okay, take your time. No issue. Is it readable to you? Actually, I'm writing
Yeah,
on the
I
screen,
can read
so
it.
I cannot write it properly.
No, it's okay. I can read it. I've finished now.
Okay. Okay, so I guess we can move forward now. You are clear with these concepts of symbols
Yeah.
and units, right?
Yes.
So okay, uh, where you are? Okay, so here we were. Now you can solve this problem. Question number one, Talha.
Yeah. So an appliance is connected to a um two 230-volt source. Calculate the resistance of the appliance if a current of 5 amperes is following through it.
So can you solve this
So
question?
we're working out um, we're working out resistance that is in ohms,
Right,
and the formula for that is potential difference equals current times resistance.
right,
And we know that the potential difference is 230.
exactly.
So 230 equals 5. Wait 1 second. Yeah, 5 times something, because we need to work out resistance.
Yes,
So then we do 230
exactly.
divided by 5.
Yes, great. So this is how you will find the answer, and what unit you will use for resistance?
Ohms.
Ohms, right? That's great. That's
The
great.
answer is 46.
46 ohms, right?
Yeah.
Okay, so there is another important concept of VI, potential difference. So I guess we will stop over here after this topic, resistance and IV characteristic. Now I guess you are very familiar with resistance, right? I don't want to
Yeah.
elaborate the resistance again, or do I need to explain it again? Resistance, are you familiar with this concept?
That's fine.
Okay, now IV characteristic. Now, what does this mean? Basically, it means a graphical representation of the relationship between current and voltage, right? So, in these graphs, basically, what we have a voltage on the x-axis and a current on y-axis, and that is why it is called IV characteristic curve, right? Now why we have voltage on the x-axis and current on the y-axis? Because we know that on x-axis always we have you can say independent variables. So and on the y-axis we always have dependent variables. Now we know that voltage is that driving force which flows the current, due to which the current flows. So voltage is independent of current, but current is dependent on voltage. So that's why we take voltage on the x-axis and we take current on the y-axis. And the graph between voltage and current is called IV characteristic. So you got my point that what does it mean by IV characteristics?
Yeah.
So, Talha, basically, what happens is that for different, you can say different components, or you can say different materials show different characteristic curves. different IV curves. Like for those, for different, you can say, components, we have different IV curves, that the relationship between the voltage and current is not always the same. Basically,
Does
so
does I and V stand for something?
yes, I and V are, you can say, I is the current we were talking about earlier, and V is
Oh,
the
and
voltage.
volt. Okay.
So have you got it?
Yeah.
So as I have told you earlier, that voltage is something which is the source of flowing current. That the current flows due to voltage, and it means that voltage is independent of current, or voltage is an independent parameter. That is why we keeps it on the x-axis, and current flows due to the voltage or potential difference. So that's why we put it on the y-axis, right?
Okay.
So till now, what we have seen is that we were discussing only a formula of V is equal to IR, right? We have seen that voltage is equal to IR. What does this means? That if voltage increases, the current increases, and if the voltage decreases, the current decreases. But there are certain devices which don't obey this Ohm's law. This Ohm's law is not obeyed by all type of devices. Rather, there are certain devices which don't obey this Ohm's law. Are you getting my point?
Yes.
So the devices which obeys Ohm's law have the characteristic curve like this. In this case, as we increase the voltage, the current will be increasing, right? So these devices which obeys this Ohm's law are called the ohmic devices, right? And in this case, in the case of ohmic devices, the value of resistance is constant, right? Are you getting my point?
Okay. Yeah.
Are you getting my point?
Yes.
But there are certain other, you can say, appliances, or other, you can say, machines, or other things, we don't obey Ohm's law. Let us say, let me give you an example of filament lamp. A filament lamp don't obeys the Ohm's law, so it will not have a straight curve like that, like the earlier one. So it have a different curve. It have a bit of like this, a bit of curve like this. It doesn't have a straight line like the earlier one had. Let me draw a straight line. Let us say,
Okay.
let us say, as we have seen earlier, that as an ohmic device, for an ohmic device, it was something like that. But in this case, you can say that it doesn't follow that straight path. Rather, it is just like it is just curved like that. So it means that the filament does not obey Ohm's law. Rather, its resistance changes. Similar is the case of diodes. We gave the potential difference to these diodes and nothing happens, and then suddenly the amount of current increases sharply with the increase of very small amount of, you can say, voltage or potential difference. So are you getting my point? So these are those devices which don't obeys the Ohm's law. So these are called non-ohmic devices. And those devices which obeys Ohm's law are called ohmic devices. Are you getting my point till here?
So filament is filament. Wait. So what's a die? How do you say it?
Non-ohmic
And
devices.
okay.
So
No,
filament,
like
yes.
diode. What's a diode?
Basically, diode is another type of components, you can say. Basically, do you know about LEDs? LEDs are examples of diodes. LEDs are light emitting diodes. What does LED stands for? LED is light emitting diode. I don't want to get deep in this topic because this is not our main topic. You need to know that diode is just an electrical component, similar to as we have the filament lamp. Similarly, we have this diode, and this is light emitting diode is an example of this type of components. So are you getting my point? Should we go in a bit detail of this diode?
Will we come across it later on? or is it
No,
now?
I guess only we need to understand till this point that a diode is just an electrical component. We don't need the detail of a diode. I don't think so. It is a part of your syllabus.
So we can go through it a bit. No, we can
Basically,
talk.
uh,
Yeah.
if we go in the depth of this diode, it is something beyond your, you can say, the level of studies.
Okay.
I can explain it to you. Basically, do you have the concepts of semiconductors?
No,
So
it's fine if I won't get it. You don't have to try and teach it because it's not in my
yes, it's
syllabus.
not part of your syllabus, so I think it will take a lot of time to
Yeah,
make you understand. So that's why I was
it's
just
fine.
avoiding this.
It's fine then. We can
So
try. We'll avoid it then.
okay,
It's-
so
Yeah.
moving forward to these things, to these concepts. Okay, let us see what is written over here in your notes. Okay, we were here, right? Okay, for some components, as the current through them is changed, the resistance of the components changes as well. Till now, we for ohmic devices, the resistance was constant, and we knew that v is equal to IR, that when the current was changing, when the potential difference was changing, only the current was changing with that potential difference. If potential difference was increasing, the current was increasing, and if the potential difference was decreasing, the current was decreasing. And in that case, the resistance was constant. So those devices which were obeying this Ohm's law were called ohmic devices. But there are certain other components through which, if the current changes, the resistance will also change, and those you can say those components or those devices do not obey this Ohm's law. So those components which do not obey this Ohm's law are called non-ohmic devices. For example, the resistance of an ohmic conductor, example a wire or resistor, does not change with current. That we were discussing about a wire or a resistor, the resistance was constant of those components. So those are ohmic devices. At a constant temperature, the current flowing through an ohmic conductor is directly proportional to the potential difference across it, and R is constant. In this, we have seen that R was constant. So are you following me till here, Talha?
Yeah.
Okay.
We went.
So
I remember doing this. Yeah, I did it at the beginning of the lesson.
you are clear, you are crystal clear till this point, right?
Yeah.
Okay, so the next thing is the resistance of some resistors and component does change. Example, a diode or a filament. We have seen here that basically we can see in these examples that when the current was changing, the resistance of these two components, the filament and diode, was also changing, right? Because do you have the concept of slope
Yeah.
in
It's when
mathematics?
it up or down
In mathematics, what does slope means? Do
in
you
graphs.
do you know the formula of slope?
Isn't it oh y-intercept
Y, yes, y2 minus y1 over x2 minus x1. This was slope,
yeah,
right?
yeah,
So basically, that's great if you know it. Basically, the slope of this VI curve gives the values of resistance. Now, if we measure the slope from these 2 points, we will get the value of the slope, and even if we measure the slope from these 2 points, we will again get the same value of the slope. So it means that resistance is same for all, or you can say the slope is same for all the points on this curve. So here the resistance is constant, but in this case, if you measure the slope from these 2 points and if you measure the slope from these 2 points, the resistance will be different, or the slope will be different. It means that the resistance is changing with current. Similarly, in case of diode, if we measure the resistance from these or slope from these 2 points, and if we measure the slope from these 2 points, the resistance will again be different. It means that resistance is not constant, rather the resistance is changing as the value of current passing through this circuit or this component is changing. So are you getting my point now?
Okay, so the resistance gonna stay constant when it's up in a slope.
Yes, when in case of ohmic devices, the resistance is same, but in
Yeah,
case of
in ohmic.
non-ohmic devices, the resistance is not same.
Okay.
So have you got my point now?
Yes.
Okay, so when an electrical charge flow through a filament lamp, what happens? Why now it is telling us that why the resistance is not same. So when an electrical charge flows through a filament lamp, it transfers some energy to the thermal energy store of the filament. You know that a filament bulb gets heat up whenever you just put your hand close to a bulb. It will be you will feel that the bulb is hot, right? So the charges that are flowing through that bulb or filament lamp, they will transfer some of its energy to the thermal energy store of that filament bulb, now which is designed to heat up. Now resistance increases with the temperature. We also you need to know that resistance have a direct relation with temperature. Now when the resistance is increasing with temperature, so the current resistance increases with the temperature, so current increases, the filament lamp heats up more and the resistance increases. That it means that as soon as more current is flowing through it, it will get more heat, and it means its resistance will always be increasing, right? So its resistance is not constant, instead its resistance is increasing with the heat. Are you getting my point?
Yes.
If you have any confusion, you may ask.
So this is for ohmic conductors.
No, this is for non-ohmic conductors. Remember that for ohmic conductors, the resistance will always be the same. Resistance will, you can say, will be constant. Resistance will never change. But in case of non-ohmic devices, as we are talking about the filament lamp, the resistance is increasing with the rise in temperature. And why the temperature is rising? When more and more current is flowing through the lamp, the thermal energy of that lamp will be increased, so that's why it will get heat up, and the temperature of the bulb will rise, and as a consequence of that rise in temperature, the resistance of the that bulb will also increase. So this is how the resistance is changing. Resistance is not same anymore. So that's why the filament will be a non-ohmic device. Do you get it
Okay.
now?
Yeah.
If you have any problem, you can ask.
Oh no, it's fine now.
Okay, so moving forward to the concept of diodes. For diodes, the resistance depends on the direction of current. They will happily let the current flow in one direction, but have very high resistance if it is reversed. Uh, should I go in the depth of this? Okay, so do you know that we have two types of currents, a direct current and an AC current, alternating current?
I don't know that.
Okay. Oh, how can I explain it to you? Okay, let us say we have a circuit and we have a diode over here. This is the symbol of a diode, right? And it is connected to a battery, right?
Yeah.
Let us say this is the positive terminal and this is the negative terminal. Now the current is flowing through this, right? Like this. Now in this direction, it will let the current to pass through it. But now if we change the polarity of this battery, let us say we connect the battery, let us say we connect the battery now like this. This is the negative terminal and now this is the positive terminal. So the
Oh
current will be
yeah.
flowing
You
like this.
switch the wires around to
Yes,
make it negative.
yes. Now the current will be moving in opposite direction, right?
Yes.
First, the diode was conducting the current, but now in this case, the diode will provide very high resistance and it will not let the current to pass through it. So have you got it?
A bit of it, yeah.
You can read this point 4 again and you will understand it what I was saying.
For diodes, the resistance depends on the direction of the current. They will happily let current flow through one direction, but have a very high resistance if it is reversed.
So have you got my
It's
point? That
like
first
a,
that
do
in
you put,
yes,
do you know diode? Do you put it in like in the circuit?
it is saying that when we put the diode in a circuit, it will let the current to flow in one direction, but it will
No,
opposes
the
the
other.
current in the other direction. We have seen
Okay.
that when the current was flowing like in this direction, it was letting the current to pass through it. But when we reversed the wires, we interchanged the wires, the and current was flowing in this direction, and in that case, the diode was not letting the current to flow through it. So the diode was providing a very high resistance, that's why the current was not flowing through it. So have you got it now?
Yes.
You can read this line 4 again and you will understand it in a better way. Break it in the pieces. Break this point in pieces. You can read it.
For diodes, the resistance depends on the direction of the current.
Yes,
They will
we have
happily
seen
flow.
we have seen that when we change the direction of current, first the current was flowing in this direction and then the current was flowing in this direction, the response of the diode was different, the resistance of the diode was different. When the current was flowing in this direction, it was easily letting the current to flow from it, but when the current was in this opposite direction, it was providing very high resistance, it was not letting the current to flow through it. So have you got my point now?
Yes.
If you have any confusion in this, you may ask Tala.
No, it's fine. I get it.
You got it?
Okay. Yeah.
Okay. So again, there is you can say a practical. You can do this practical by yourself. I don't think so. It's or we can do it. Let us do it again
Like next
together.
person, maybe.
Sorry.
Oh, nothing. Never mind.
Okay. Talha, the important thing about this topic was these graphs. You need to remember these graphs because in exams, he often asks to draw the VI characteristic curves for filament lamp, for diode, and for ohmic conductors. So you need to remember these three graphs, right?
Okay.
There is, you can say, there is also a question over here that draw the IV characteristics curves for an ohmic and a filament lamp. But you need to know about the, you can say, diode as well, right?
Yeah.
So let us discuss the practical as well. Okay, the term IV characteristic refers to a graph which shows the how the current I flowing through a component changes as the potential difference across it is increased. That what does IV characteristic means? IV characteristic is basically a graph between current and voltage. And what does it shows? It shows the variation of current with voltage. That how if the voltage is increasing or decreasing, how the current will increase or decrease, right? Have you got it?
Yeah.
So okay, now moving forward. Linear components have IV characteristic that's a straight line. That for ohmic resistors or ohmic conductors, we have a straight IV characteristic curve, right? As we have seen here, right? Why this is so? Because in these cases, or in this case, basically the resistance is same, so the resistance is not changing, so that's why the curve will not change. Rather, as the potential difference will increase, the current will increase accordingly linearly. So have you got my point?
Yeah.
If you have any confusion till now, you can ask Tala.
Um. So I understood ohmic. Wait.
Mhm.
Okay, actually, never mind. It's okay.
You can ask Tala. Why are you just hesitating? Please do ask.
Can you like scroll up a bit? Just
Sure.
coming down here. So I understood the ohmic conductors and diode,
Right.
but for a filament lamp, is that for when the temperature increases?
Okay. Let me tell you this. We see that when we increase the current, the current will provide energy to the thermal energy store of the filament, right? So the bulb will get heat up. Now as the temperature of that bulb is rising with that heat, the resistance
Yeah.
of that bulb will also be increasing. So resistance is not same anymore, rather it is increasing with time. So that's why it doesn't have a linear straight graph, rather it have a
Oh,
curve like this. So have you got my point?
that's why it's lost a bit.
Yes, it's not straight, rather it's curved. So this is not an ohmic conductor, it's a non-ohmic conductor. So have you got my
Okay.
point now?
Yeah, I get it now. That's why I had a doubt in a bit. That's
Now is
fine
it clear?
now. Yeah.
That's great. That's great. Okay, so you can do this experiment to find the component's IV characteristics. Set up the test circuit as shown on the right. You need to build a circuit in your lab like this. You need to connect a battery, an ammeter, a voltmeter, and a component across what you want to find, and a variable resistor. Now, in the second step, begin to vary the variable resistor. This alters the current flowing through the circuit and the potential difference across the components. Now you need to focus on one thing. You can see that this is the component across which we want to find the voltage and current. You can see that voltmeter is connected in parallel to this circuit. Have you seen it? And the ammeter is connected to this component in series. Have you noticed it, Talha?
What do you mean?
As we were discussing earlier, that whenever we put an ammeter in a circuit, we
Oh
place it
yeah.
in series, and in case of parallel, in case of voltmeter, we put it in parallel. So here you can see that voltmeter is placed in parallel with this component across which we want to find the voltage, and the ammeter is connected in series to this component through which we want to find the flow of current. So have you
Oh
noticed it
yeah.
now?
Yeah, no. It's always like this, am I right?
Yes, it will be always like this. That ammeter must be in
Okay.
series and voltmeter must be in parallel.
Okay.
So you need to develop a circuit like this. You can change the resistance of the circuit from this variable resistor. When we decrease this resistance, the current flowing through this component will be increased, and when we increase this resistance, the current flowing through this circuit will be decreased. So you can vary the resistance in order to vary the current flowing through this component. Now take several pair of readings from the ammeter and voltmeter. Take different readings from ammeter and voltmeter to see how the potential difference across the component varies as the current changes. Repeat each reading twice more to get an average potential difference at each current. Now then you can take many readings and then take the average of them, and then you can put it in the graph by putting different values. Then you will have an IV graph for different components. If here the component is an ohmic device, you will get a IV curve like this. If here the component is a filament lamp, you will have a curve like this, and if you here you have a diode, you will have a curve like this. So have you understood this concept?
Yes.
If you have any confusion, Tala, you may ask.
No, I don't have any now. It's clear.
It's clear.
Yeah, it's clear to me.
So now you need to learn these characteristic curves. Remember these characteristic curves because these are very important. Now there are two other things. Okay, so let us finish our lecture over here. We have two other things, an LDR and a thermistor. Basically, an LDR and thermistor both are resistors. As we have seen these resistors now, these are simple resistors, but LDRs and you can say thermistors are a bit different in shape. I can show you thermistor and LDR as well. Let us have a look at these thermistors. Thermistors look like this, right?
Yes.
And let me show you LDR. And LDRs look like this, right? Basically, all these are types of resistors, but these resistors had the constant values. The values of the resistance of these resistors does not vary. But in case of thermistor, like when you have this component in a circuit, the resistance of the circuit or resistance of this thermistor varies with the temperature. At high temperature, you have low values of resistance, and at low temperature, you will have high values of resistance. And in case of LDR, LDR stands for light depending resistors, right? If you have more intense light, the value of the resistance of these components will be small. But if you have dim light, the value of resistance will be high. So have you got my point? What does LDR means?
So it's like a different type of resistor.
Yes, a different type of resistor whose the values of this type of resistor is depending upon the intensity of light, right? That if the light is more intense, the resistance of this type of resistor is more, and if the light is intense, the resistance will be small, and if the light is dim, or you can say we have low light, then you can say the resistance will be high. So have you got my point?
Okay. Yeah, I get it now.
So okay. So these
Better.
are LDR and thermistors we have discussed. Okay. So moving forward, LDR is basically, it means that resistance depends upon different things. Resistance, you need to keep in mind that resistance depends on temperature and resistance depends on light as well. So LDR, what does LDR stands for? LDR stands for light dependent resistors. It means that light affects the resistor, and LDR is a resistor that is dependent on the intensity of light. In bright light, the resistance falls. It means the value of resistance decreases with the increase in light, and in darkness the resistance is highest. So the same thing which I was telling you earlier. Yeah, have you got it now?
Yeah.
So they have lots of applications including automatic night lights. The you must have seen those roadside lights, right? They just automatically turns on and turns off.
Oh yeah.
So how this happens? Basically, that LDRs are used in that circuits, and if we have dark, the resistance of a circuit, you can say, let us say, let me give you a general overview. It's not specifically like that, but it's a general overview. Let us say that we have this street light and it is connected to this LDR, right? So, and there is some voltage source or current source. Now, what happens? If the intensity is high, right? If the intensity is high, an LDR is connected over here, let us say, right? If the intensity is high, intensity of light is high, it's daytime. Now what happens? The resistance of this LDR is small, right? Now when the resistance is small, so current, instead of flowing through towards this bulb, it will flow through this, right? So it will not flow to the bulb. But when it gets dark, the resistance of this LDR will be very high, so that current will not pass through it. Instead, the current will move towards that light and it will pass through the circuit of light and light will turn on. So have you got it or not?
Mm, yeah, I get it now. It's good.
So this is how the roadside lights work, and LDRs are used in this. Similarly, outdoor lighting and burglar detectors are also used LDRs. Similarly, thermistors. I have told you earlier that thermistor is a type of resistor which depends upon temperature. So a thermistor is a temperature dependent resistor. In hot condition, the resistance is low, and in cold condition, the resistance goes up, as I have told you earlier. So where the thermistors are basically used in different type of temperature detectors. For example, in car engines or temperature sensors, thermistors are used. So these are the things which you have seen, which we have seen, that what does LDR means and what does a thermistor means. So there is also an you can say an assignment. Take this as a home assignment. You In the next class you will discuss an application of LDR and a thermistor to me. Okay.
Okay. Yeah.
So I guess it's enough for today, right?
Yeah, so now it's been two
So,
hours.
so in the next lecture, we will be discussing about you can say series and parallel circuits, and we will see we have like covered these topics, but again we will see it in a bit detail. I hope these series and parallel combinations are clear to you, I guess.
Yeah.
So we will see
That
that.
I might need to do a bit of like revision so
Yes,
I fully understand. But
please
yeah.
do revise these topics, and if you feel any problem, please do discuss it with me. We can again discuss this, you can
Okay.
say.